Hello everyone, welcome to New Wave Coaching Classes for Mathematics. This is your host Jatin. Today we are going to study about a very new object which is called as frustum of a cone. Before we talk about frustum of a cone, let's understand about the frustum, but actually it is a frustum. So we have already studied about the cone. This is the shape of the cone. If we cut this cone horizontally parallel to its base, if we cut it parallel to its base, we will left with something which will be shape of like this and this shape, right? And this shape, obviously this is the glass, and this shape is basically called as frustum of a cone, right? And let me draw the figure of this now on the board. Now you can see in this figure there are two circular bases, right? 1 and 2. So obviously it has two different radii. The radii which is longer in length, we take it as R1. Shorter one, we take it as R2. Then we have a slant height. We take it as L, and then we have a vertical height also. We take that thing as small h. Now these are basically the meanings of the symbol. Now what else we want? We want to know these things. Curved surface area. Now what would be the curved surface area of a frustum? So we are not going in the derivation, we are just writing the formula, learning the formula directly only. Just writing this h a little bit more prominently. So this is pi multiplied by R1 plus R2 multiplied by L. This is the formula to find the curved surface area of a frustum. Then we go to the second thing, that is the total surface area. Now it's quite understandable that when we talk about the total surface area, what we are doing, this is the curved area, this portion. When I have to find the total surface area, what I have to do, I have to add the both the bases. One base, this one, and one is at the bottom. Now this base is basically a circular base, and the area of the circle is pi r square. Now in this case, since the radius is R1, I will be adding pi R1 square, and then this one, it will be pi R2 square, right? So in curved surface area, along with the curved surface area, we'll have the area of both the bases, that is pi R1 square plus pi R2 square, right? Now we go to the third thing, which is the volume. Now, as we know that since it is a part of a cone, it's a frustum of a cone, truncated cone, you can also call it as, and the volume of the cone is basically 1 by 3 pi r square h, right? So here also, when we start with the volume, it is basically 1 upon 3 pi, and inside the bracket we have R1 square, R2 square plus R1, R2 and multiplied by h. So this is the formula of the volume. So using these formulas, we will be doing the questions of exercise 13.4 now. Right. So the first question of exercise 13.4 is quite simple. Now it's given a drinking glass is in the shape of a frustum. So we have a drinking glass. You can see this. right? And it's given that the height is 14 centimeters. So the height is given as 14 centimeters. Let's draw the diagram first. So we have a drinking glass, something like this, right? And the height is given as 14 centimeters. So this is 14. What next? The diameters of its two conical ends are 4 centimeter and 2 centimeter. So this is given as 2 centimeter and this is 4 centimeter. And what we need to find is basically the capacity of this glass. Now, capacity means we have to find the volume and then we have to convert it into milliliters or liters. That is why we call it as capacity. So let's see what is given. Height h equals to 14 centimeter. Now the diameter is 4 and 2. So the radius would be, see, the bigger one is R1. So R1 here will be half of this, that is 2 centimeter. And R2 obviously will be half of this, that will be 1 centimeter. Now this is the formula for the volume. So volume equals to 1 by 3 pi R1 square plus R2 square plus R1 multiplied by R2, and then outside bracket we have h. Substituting the values, we get it as 1 by 3 multiplied 22 divided by 7 multiplied inside the bracket we have 2 square, that is 4, 1 square, that is 1, and R1 R2, that is multiplying these two. So what we get? 2. Again R1 square, this is R1, the value of R1 is 2, so this is 2 square, I get it as 4, and then R2 is 1, so 1 square is 1, and then multiply R1 and R2 and then I get is 2, and h obviously is 40, so here it is. So this is now 1 by 3, 22 upon 7 multiplied by 7 into 14, the 7 cancels, and what we get is 308 upon 3 centimeter cube. And we can also write it as 308 upon 3 milliliters. Right? Why? Because 1 centimeter cube is equal to 1 milliliter. Now let's go to the next question. The slant height of a frustum of a cone is 4 centimeter and the perimeters of its circular ends are 18 and 6 centimeter. Find the curved surface area. Now in question number 2, let's draw the diagram first. Something like this. Now it is given that the slant height is 4 centimeter. So this is 4. Right? And what else? This slant height, this is not the vertical height, but the slant height is given as 4 centimeter. And they say the perimeter of the circular ends means the length of this complete. This is called as circumference. Now the circumference of the bigger base is given as 18 and the circumference of the smaller base is given as 6 centimeter. Now what I have to find? I have to find the curved surface area. If we see, the formula is pi r1 plus r2 into L. It means the radius is not given to us. But what we have the perimeter or the circumference. So using the circumference, we will first find the radius of both the flat surfaces, right, for both the bases. First we will find the radius and then we substitute the values of the radius in the formula and then we can find the curved surface area, right? So now, slant height L equals to 4 centimeter. Let me confirm, is it 4? Okay, yes. Now, the circumference of bigger base is 18 centimeter right? And that of the other is 6 centimeter. Right. Now the formula for the circumference is 2 pi r. Now since what we take bigger one as r1 and the smaller one as r2. So we can write it as, this means 2 pi r1 equals to 18. So we get r1 equals to 18 upon 2 pi. Or we can say that r1 equals to 9 upon pi. Right? Similarly, 2 pi r2 equals to 6. This means r2 will be 3 by pi. See, I am not substituting the value of pi because pi later on gets cancelled. So just I put substitute the value of curved surface area. Now CSA is equal to pi r1 plus r2 multiplied by L. Substitute the value. This is pi. Inside the bracket, I have 9 by pi plus 3 upon pi. And outside the bracket, the value of L, that is 4. Now, we can take this pi as common outside and it gets cancelled. And then what I am left with is 12 multiplied by 4. Okay, let me show you how I am saying it out. So this is pi. If you take the LCM and simplify, this becomes 12 upon pi. That's the other way. And this pi cancels. So what I got, this is 48 centimeter square. So this is the solution of question number 2. Now let's see the question number 3. In question number 3 is given a fez, that's the name of a cap. The cap used by Turks is shaped like frustum of a cone. If its radius on the open side is 10 cm, radius at the upper base is 4 cm and its slant height is 15 cm, find the area of material used for making. Now again, it is shown something like this. It's shown something like this. We have one face as open and another is closed. Now obviously the fez cap is open from this side, so you can keep on the head like this. So this one is open. Now what I have to find, I have to find how much material will be used in making this cap. So for that, what would be required? The curved surface area, because the material is being used to make the curved surface area, and the area of the one of the base, that is the smaller base, because the bigger base is open. Let's draw the diagram first. Right. Now the measurements which are given to us is, okay, the slant height is given, and the radius of both the sides is given, both the bases, 10, 4 and 15. So this is given as 10 centimeter, this is given as 4 centimeter, and this is given as 15 centimeter. That is the slant height of this cap. So L is equal to 15, R1 is equal to 10 centimeter, it's not clear, and R2 is 4 centimeter. Right. Now we need to find the area of material used in making the cap. So that will be equal to, now first we add the curved surface area, so that will be CSA plus area of smaller base. Right, so we write it as pi R1 plus R2 multiplied by L plus smaller base is pi r2 square. We substitute the values now. So we take it as pi. We can take pi common also if we want to take. So we take pi common. So inside the bracket it will be r1 plus r2 multiplied by L plus r2 square. Something like that. So now r1 is 10, r2 is 14. So this is 22 upon 7 multiplied 10 plus 14 multiplied by 15 plus R2 is 4, so we have 4 square. So this is 22 upon 7, this will be 14 multiplied by 15 and plus 16, right? And when we simplify this, what we get after simplifying this thing? So this will be 22 upon 7 multiplied by this 14 into 15 will be 210 and plus 16 it will be 226. So now we multiply these two. So it will come 6, 10, 9 and 4 upon 7. So when we divide this thing, we get the answer as 710.28 centimeter square, right? There is a slight mistake here. This is 4972. So we get it as 710.28 centimeter square. So dear friends, this was about frustum of the cone and some of its questions from exercise 13.4. The remaining two questions we'll be doing in the next lecture. Till then, make sure to like the video and subscribe to my channel. If you have not understood, I request you to just go and watch the video again. This is your host signing off. Goodbye and take care. Bye-bye.